All right, what's up guys? Mr. Fabella here, continuing our probability lessons. We've done a whole bunch. We've done simple, we've done probability of multiple events, we use sample size and all those different things. Right now we're going to do probability of independent and dependent events. So it's going to look very, very similar to probability of simple events and multiple events, except now you're going to have to decide when two events happen, does one event depend on another event? Here. So yeah, independent events, I'll put a description or a definition up here, but basically independent events, whatever happens to one thing does not affect the other event. So like if I toss a coin and I roll a die, tossing the coin does not affect what happens to the dice roll. Dependent events, that's when the first event affects the next event or whatever other event there is. So if like I had a bag with everyone's name on it, if I pulled out one name and I kept it out, the probability that someone else's name will be called or picked is actually different than if the name was still in there, because the denominator changes. So I'll put definitions here and also give more examples as we go along. Okay. So let's take a look at the probability of multiple events and mutually exclusive events, also called independent probability. So let's look at this. A bag consists of 3 red, 4 white, and 2 blue marbles. Find the probability of the following if the marbles are replaced after each draw. So some people call this probability with replacement, without replacement. Probability of getting red, comma, and then red again. So that means you pick a red marble, most probably getting that, and then putting it back, and then get a red marble again. So it's hard to visualize, so let's look. Let's say that you have a bag of red marbles, right? The probability of getting red, so there's 3 out of 1, 2, 3, 4, 5, 6, 7, 8, 9. So 3 out of 9 is a probability of getting 1 red marble, right? So it's 3 out of 9. You put that marble back. The probability of getting a red marble again is still 3 out of 9. So when you're trying to find the probability of this event and then this event happening again, you multiply. So 3 nines times 3 nines, don't waste your time multiplying that. You should actually reduce it to 1/3 times 1/3, and you have 1/9. So the probability of getting a red marble, looking at it, putting it back in, get another red marble, that is 1 out of 9. So it's the probability. So the probability is 1 out of 9. Again, probability of getting a white marble, then a blue marble, then another blue marble, and you keep putting it back. So white marble there is 4, and you already know it's 9. So 4 out of 9. The blue marble, there's 2 blue marbles there out of 9. So 2 out of 9, and then times 2 out of 9 again. See if you can cross cancel anything. Unfortunately, you cannot. So you're going to end up with a big number, 16 out of 729. So that is your probability of getting white, blue, and then blue with replacing it. A tip, if you are doing a fraction, if you cannot reduce anything when you're looking at it written as a product, so 4 nines times 2 nines times 2 nines, that means your final product, 16 over 729, is reduced as much as possible. All right, so dependent events. So what we did before was independent events. One event didn't affect the next event. So now we have the same scenario. 3 red marbles, 4 white marbles, 2 blue marbles. And now it's saying find the probability if the marbles are not replaced after each draw. So like you pick it, take a look, go, no, I don't want this, and then you put it back. The probability of getting red and then red again. So if you remember before, the probability was 1 out of 9. Let's see if it's the same thing. So we have here, right now the bag is full, right? So it's still 3 out of 9. So nothing changed from the first step of the last thing we did, right? But it's without replacement. So you took the marble out and you left it out. Like if I picked names out of a hat, I would pick a name, this person is in this group, I wouldn't put it back in, like they're already done. So here, if you think about it, you take away one of the red ones, and now you count. There's 2 red, and it's not out of 9, because if you took a red marble out, there aren't 9 marbles anymore. It's 2 out of 8. Okay? And then again, reduce so you can have a nicer fraction to work with. So this is 1/3 times 1/4, which is 1/12. So 1/12 is less likely than 1/9 because you took one of the red marbles out. All right, so let's do the same thing. White, then blue, then blue. So we're starting with the full bag again. Probability of getting white is 4 out of 9. That's fine. But I took the white marble out. So the probability of getting blue, there's still two blue marbles, but it's not out of 9, it's out of 8. So it's 2 out of 8. And then I take out that blue marble and leave it out. So now there's only 1 blue marble, and not 8, there's only 7. And then you just multiply across. Okay? Reduce where you can, and you are left with 8 over 504, or 1 out of 63. And we didn't check the percentage last time, but 1 over 63 is less likely than the previous answer if there was no replacement. Okay, so out of the book, the probability of two independent events can be found by multiplying the probability of the first event by the probability of the second event, just like we did earlier, 1/3 times 1/3. So going back to independent probability, the letter tiles, whatever you pick on the letter tile does not affect the spinner. Okay, so what's the probability that both will be a vowel? So first of all, what's a vowel? A, I, O, U. So we have E and A here. Right? So the probability for a letter tile to be a vowel is 2 out of 4 times how many vowels are up here? We have an A over here. That is 1 out of 3. Okay, so the probability that both would be vowel, you would just reduce this to 1/2 times 1/3, and it's 1 out of 6. So the probability that both would be vowel is 1 over 6. Okay, another example here. Two spinners below are spun. What is the probability that both spinners will show a number greater than 6? So you have to know greater than. So don't include 6. So greater than 6 is 7, 8, 9. So that's 3 out of, there's actually 10 here, because 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 0, that's 3 out of 10 for the first one. This one is the same thing. They're the same spinners. So 1, 2, 3. 3 out of 10 times 3 out of 10 is 9 out of 100. So there's a 9% chance, because that's easy to see, there's a 9 out of 100 chance that both spinners will show a number greater than 6. Okay, going through this quickly, the spinner and number cube are shown. So spinner and number cube, they don't affect each other. What was the probability of the player not spinning blue, then rolling a 3 or 4? So not spinning blue. Okay, so that's yellow, green, red, and purple. 1, 2, 3, 4. That's 4 out of 5 to not spin blue. And then rolling a 3 or a 4. So a number cube, you can roll a 1, 2, 3, 4, 5, or 6. So rolling a 3 or a 4, that's 2 out of a 6 possible. And then let's make these easier. So 4/5 times 1/3, that gives me 4/15. So there's a 4/15 chance that you will not spin blue, and you'll roll a 3 or a 4. Okay, so now for the kind of more interesting stuff to me. Dependent events. If two events, A and B, are dependent, then the probability of both, same thing, you multiply the two probabilities, but here it says the probability of B following A. Like, you have to do A first, and then what's the probability of B after A happens? So you have to assume that A happens. There are 4 oranges, 7 bananas, and 5 apples in a fruit basket. Ignacio selects a piece of fruit at random, and then Terrence selects a piece of fruit at random. Find the probability that 2 apples are chosen. Okay, so let's find out. So total, because you want to know what the denominator is going to be. So how many pieces of fruit are there? So there's going to be 16 pieces of fruit. Okay, so let's see. 2 apples are chosen. So Ignacio takes it, he keeps the apple, and then Terrence selects a piece of fruit and keeps it. So apples, there are 5 apples out of 16 total. Okay, then one of the apples are taken away. Now you have 4 apples. The total then goes to 15. So you have 4 apples out of a total of 15 because one of the apples got taken out. All right, so let's cross cancel first. So everything looks nice. That's 1 and 4. This is 1 and 3, because I don't want to multiply 16 times 15, so I'm left with 1 out of 12. So there's a 1 out of 12 chance that 2 apples are chosen. All right, this is an example question from Alex. A box contains 2 plain pencils and 6 pens. All right, that's box 1. A second box contains 7 colored pencils and 5 crayons. Okay. One item from each box is chosen at random. What is the probability that a plain pencil from the first box and a color pencil from the second box are selected? Right answer is a fraction in simplest form. So first, let's see, is this dependent? Because there are two different boxes, right? So I do not think this is dependent. I mean, I don't think this is dependent. Yeah, this is independent. Plain pencil from the first box. So plain pencil, that's plain pencils out of 8. Not 2 out of 6. It's 2 out of 8 because there's 8 total writing utensils there. Okay? And then probability and a color pencil from the second box. So 7 color pencils out of 12 because there are 5 crayons there. So let's see, this is 1 and 6, nothing else. So this is going to be 7 out of 48. And that's in the simplest form. Bag contains 10 marbles, 2 are green, 6 are red, 2 are blue. Dan chooses a marble at random and without putting it back, chooses another one at random. What is the probability that the first marble is green and the second is red? Write your answer in simplest form. Okay, good. So it's one bag, just like the example that we used, and he didn't put it back. So let's see, the first marble is green. So that's, the order matters, right? The order does matter. So the first marble is green. There's 2 green. 2 green out of, it says 10, so 2 out of 10. And the second is red. So I took away a green, so there's only 1 there. There's only 9 marbles left. So now the second is red. There are 6 red. There's still 6 red ones in there. I didn't take one out, but I took away a green one. So that means there's only 9 marbles left over. So 6 out of 9. So let's see, let's reduce this to 1/5 times 2/3. And that becomes 2 out of 15. So the probability of getting the first marble is green, the second marble is red. There's a 2 in 15 chance that happens. Okay, and last example. There are 4 red, 8 yellow, 6 blue socks mixed up in a drawer. Once the sock is selected, it is not replaced. Find the probability of reaching the drawer without looking and choosing 2 blue socks. Let's find the total first. That's 18 socks. Choosing 2 blue socks. So I'm going to choose a blue sock. That's 6. 6 out of 18 blue socks. 6 out of 18 blue socks. That means I took one away because I found a blue sock. It's good. Now I have 5 left and 17 total socks because I took away one of the socks. So to get a second blue sock, it's 5 out of 17 chance. And let's try to reduce this as much as possible. Okay, so this is going to be 5 out of 51. 5 out of 51 chance that you go in there, you pick one blue sock, worked out, put it aside, pick another blue sock. All right, so hopefully this was helpful on understanding the probability of independent and dependent events. And I'll see you guys next time.